So sometimes we have to introduce more than one variables to describe the relationships among the different quantities in the question. But okay, those does not involve squares, radicals. So usually written in the linear form, so that's called linear equations. Okay, and if you have two variables, usually we need two equations in order to uniquely determine those two variables. Okay, if there are three variables, we need three equations to determine the individual values, right? Of the values of individual variable, okay? So in the applications, right? We sometimes do need two variables instead of one to solve equations, okay? To solve the problem. Now, let's practice on the system linear equations first before we apply them to solve a more complicated starter problems. Okay. Okay. So let's begin with the following. Okay, we are given two equations. Okay, and the first equation is x minus y equals -3, and the second equation 2x plus y equals 1. And we want to determine the value of those two values of the values of those two variables x and y. Okay. Now we have two equations here, right? So there are several ways to solve the problem. The first method we call the substitution method. The second method called the elimination method. Sometimes in the process of solving the equations, we use both methods. Okay. Okay. So I'm going to call the first equation 1, the second equation 2. So what I'm trying to do is we call the elimination method. Elimination method, the elimination method is just eliminate one variable by adding two equations or subtract two. So equation 1 plus equation 2. Then in the left-hand side, you will see you have -y and +y. So y will become x plus 2x will be 3x. The right-hand side is just a -3 plus 1, so it's -2. So x will be -2/3. Okay. Once you get the x value, you can get the y value. You can use any of the equation, like equation 2. Y equals 1 minus 2x, right? And that is 1 minus 2, -2/3. Now be careful here, negative becomes positive. So it's 4/3. And then 1 plus 3 is 7, 7/4. Because that's it. You don't need to to use decimal numbers to describe it. Okay. The second method called the substitution. Substitution is instead of eliminate one variable quickly, we solve y by the first equation. We express y in terms of x, for example. You move y to the right-hand side and move 3 to the left. So y equals x plus 3. Okay? Then you plug it into the second equation. Okay? Now, in the place of y, you replace it by x plus 3. And that is going to be 1, right? So this is as a place of y, okay? Right, 2x plus y equals 1. So now you have a 3x plus 3 equals 1, okay? Then 3x equals 1 minus 3 is -2, and x equals -2/3. Now once you get this, then you go back to the first equation again, then y equals x plus 3, so -2/3 plus 3, and add them together, right? And then 9 minus 2 is 7, so 7/3. Okay, so there are two different ways to solve the problem. Okay, substitution method means you solve the equation, solve one of the equations, and for y or for x, it doesn't matter. Okay, and if you solve for y, then you express y in terms of x. Then you replace the y in the second equation by x, by the expression in terms of x. Okay, then you get a single equation with a single variable, and you solve for that variable first. Okay, right? So that's the idea. Okay, and depends on the problem. You know, sometimes you prefer using elimination method, sometimes you use a substitution method. Okay, so our next problem, for example, x minus 2y equals 9, x plus y equals -5. Okay, so please please solve this using any of the method. Okay, and you have two equations here, right? Okay. You can eliminate one variable immediately by subtraction, not addition. Okay. Yeah, I prefer, if there's a quick way to eliminate the variable, I prefer elimination method. Okay. So you can say equation 1 minus equation 2, or equation 2 minus equation 1, doesn't matter. So x minus x is gone, but negative 2y minus y will be -3y. 9 minus -5 is 9 plus 5, right? That's going to be 14. Okay. So then y equals -14 over 3. Right? Then you can use any of the equation to get the x variable. Let's use the second equation. That's be minus y minus 1. -5 minus y, so it's -5 minus -14 over 3. And then let's simplify it. Okay, so 14 minus 15 is -1. So it's -1/3, -1/3. So you get x and y. There, you get x and y. All right, now I'm going to ask you to do the next problem. Okay, I'm not going to do that for you. Okay, so you're going to get 2x plus y equals 1. Okay, then 3x minus y equals 5. Yeah, please do this for practice. Okay. If you get an answer, you can post it on the window. Okay, chat window. All right. Hey, are you able to get it? You usually get the fractions, okay? Michael Pooh, Michael Dean. Any of you have answers, please let me know. Yeah, equation 1 is 2x, not 12. 2x plus y equals 1. Right. You have to give me the answer like x equals some number, y equals some number. So Andrew has the answer, yeah. Okay. Okay. Right, just like what I did, you have to get the values for x and y, which satisfy those two equations. You have two variables and two equations. You can try your best. Okay. Okay, I have a comment. Jaden, okay, you only get x. Do you get the y? If x equals, you have to double check. You know the yeah, you have to get x and y, and both equations should be satisfied. Okay. I prefer fractions. Don't change it to the decimal numbers. Okay. So it's better to put as a fraction. Okay. Yeah. Lucial, yeah, please, yeah. Just use the fraction. You don't need to do additional computation to give me the number in decimal form. Okay. Okay, Andrew, do good. And anyone else? Michael Dean, are you able to solve the problem? And Jaden. Right. Okay, look at these two equations. We call the equation 1, right? Equation 2, I prefer to eliminate the variable. And so you can see that equation 1 plus equation 2, all the terms on the left side add up together. The reason I use adding them together because I see positive y, negative y. So when they add them together, come. So 2x plus 3x will be 5x. The right-hand side, 1 plus 5 is going to be 6. You see, from here, x is going to be 6 over 5. So you get x over 5 immediately. Right? Then you can use any of the equation. Again, let's use the equation 1. Equation 1, y is going to be 1 minus 2x, right? So 1 minus 2, what is x? 6 over 5, and simplify it. If you simplify it, you will get 1 minus 12 over 5. 12, right? 12 over 5. Right? 12 over 5, what's the 7 from? Okay, so let's double check, okay? Y equals 1 minus 2x, right? From the first equation, you move 2x to the right-hand side, right? And then what is x? X is 6 over 5. So you plug a 6 over 5 there. Then you get 12 over 5 on the top. And then this way 5 minus 12, it's going to be negative 7 over 5. Okay, so you get, finally you can write like that, x equals 6 over 5, y equals negative 7 over 5. Okay, that's good. Yeah, great. Okay. Now there are some other problems. It's not easy to use any of the method. Okay, like 3x plus 2, y equals, equals, for example, let me check. Yeah. Okay, let me let me put a good number there. Okay. Okay, let's use this. Okay. So that's equation 1, that's equation 2. Now, you use either of the method, you will get a fraction. I don't like a fraction. Fractions, it's complicated. It's easy to make mistakes. Okay. If you use a substitution, you have to solve for y or solve for x in terms of x from the first equation. When you involve fractions, it's getting complicated. If you use the elimination method, I cannot eliminate the variable immediately. Okay. But that's okay. Now we can do like this, okay? Equation 1 plus equation 2. So the 2x plus 3x will be 5x. 3y plus 2y will be 5y. And then 13 plus 12 is 25. Yeah, I do not eliminate a variable, but I get a much simpler equation. Both sides divided by 5, so it can be x plus y is 5. Now that's equation 3. Equation 3 comes from equation 1 and equation 2. All right. So then you can use a substitution. So y equals 5 minus x, right? And you plug into any of the equation. Let's say equation 1. Right? If you plug into equation 1, there's 2x plus 3. What is y? Y 5 minus x equals 13. All right, so let's simplify it. 2x plus 15, 3x equals 13. All right, 2x minus 3x is negative x. Okay, and then from here, clearly x should be equal to 2, right? We don't need to waste time today. So x is 2. If x is 2, then you can use a third equation. The third equation is much simpler. So y equals 5 minus x. So it's a 5 minus 2, which is 3. So we get two solutions. X equals 2, y equals 3. Okay, x equals 2, y equals 3. Okay, this is just one of the methods to solve it. I can try another way to do it. Okay, so let's do it. 2x plus 3y equals yeah, we have a 13 and 12, right? 13 and 3x plus 2y equals 12. That's equation 1, equation 2. I still want to use the elimination method, but I cannot just add them together. What I'm trying to do is, if I want to eliminate the y, what I'm going to do, I'm going to multiply the first equation by 2. So I get 4x plus 6y equals 26. Okay, that's equation 1 prime. Then I multiply equation 2 by 3. So it'll be 9x, 2 times 3 is a 6y, equals 3 is 36, right? Right. So that's equation 2 prime. Then you will see I have the same y here, so I can use subtraction. Then I can say equation 2 prime minus equation 1 prime. And then modify each equation by, right? Then now 6y is gone. So 9 minus 4 is 5x. 36 minus 26 is 10. So x is going to be 2. Okay? Once x equals 2, you can use any of the equation by equation 1. So it's 2. Equation 1 is 2x. Let me copy this equation. Right? It's going to be 13. So 2 times 2 plus 3y equals 13. Right? So now it's a 3y equals 13 minus 4. It's going to be 9. So y equals 3. Okay? Okay. So there are many ways to solve an equation. All right, so this method I just mentioned to you can be used to solve the next problem. Okay, this is from math computation, but I'm going to change the number. I'm not going to change it, but just exactly it's the same number. 776 plus 777y equals 775. And 777x plus 778y equals 776. Wow. So find the solution. Okay. All right. So I will let you to think about how to do that. You cannot use a substitution. You cannot use the elimination method directly. So what I'm trying to do is to try and get a simple relationship between x and y. Okay, that's equation 1, equation 2. Okay, let's try. This is the math computation problem. To make this bigger number, just want to scale. You know, if you use a stupid method, then you can solve it, but it's very complicated. Okay, I'll give you a minute to think about, and then we have plenty of time to, yeah. Yeah, Michael has some ideas. All right, so we do we find out 777 is one more than 776. So let's do equation 2 minus 1. That's Michael's idea, right? Let's try this. So then you get x, and 778 minus 777 is also 1, and 776 minus 775 is 1. So wow, this is the equation really good, much simpler. Okay. Then once you have this equation, you can use a substitution like a y equals 1 minus x. I'm going to put it, plug it into equation 1. Okay. And so 7776. Okay, what? 2 more 7s. Yeah. Okay, x plus 777, 1 minus x. Okay, and from here you definitely can get the x, right? All right. So, so this 2 gives you negative x, right? And also move 777 to the right-hand side. Right? I got negative 2. So x is going to be 2. And once x is 2, y is going to be 1 minus x is 1 minus 2 equals negative 1. Wow. So that's it. You got 2. You get 2 solutions. You get solutions. X equals 2, y equals negative 1. Surprised. Okay. Yeah, sometimes you combine 2 equations and into a simple equation. And use that simple equation, use a substitution to finally get to equation in 1 variable, okay? Then, use that simple equation, you solve for x or solve for y. Then you plug it into one of the above equations, then you get the equation in 1 variable and you solve it. Now, there are some equations written in slightly different form, like this one. X to y equals 3 to 2, and 3x minus 7y equals 5. Now, this first equation essentially is going to be like that, x over y equals 3 over 2. Now, this does not look like a linear equation, but this equation, if we do the cross product, is 2x equals 3y. That is a linear equation, right? It also can be written as 2x minus 3y equals 0, okay? So the equation, here, x to y equals 3 to 2 is actually 2x minus y equals 0. But I'm not trying to use 2x minus y equals 0 to solve this system of equations. What I'm trying to do is use this ratio, okay? Because x to y is 3 to 2, so you can let x to be 2, x to be 3t, for example, t is some number, y equals 2t. So x and y must be related in this form in order to keep the ratio equal to 3 to 2. Okay, and using that, and you plug into the second equation. So then the first equation is satisfied, right? It's satisfied. This coming from the first equation. Then by the second equation, right, you get 3t, 7, 2t equals 5. Let's determine the variable t. So it's 9t, 14t equals 5. It's negative 5t equals 5. All right, t is going to be what? T is going to be negative 1. T is going to be negative 1. Once t is negative 1, then you can get the x value and the y value. Then x equals 3t, so x is going to be negative 3. Right? X is going to be negative 3, and y equals negative 2. And that's the best way to do it once you see the ratio of the two variables. Okay. Yeah. Now, I just said that sometimes at the very beginning, the equation does not look like a linear equation, but after you modify it, it's indeed a linear equation. Okay. Here's another one. 1 over x minus 1 over y equals 1 equals 1. 1 over x plus 1 over y equals negative 2. Now, these two equations, no matter how do you modify it, never be linear equation. If you just modify direct, never be a linear equation in x and y. Right? Right. Yeah, for example, this equation looks like y minus x equals x times y. It's not a linear equation, right? So we're not going to use that. Right? And it's not a linear equation. Why it's not linear? Because there's x times y here. Okay. How do you do that? Well, don't modify it. All you have to do is just view 1 of x as one variable, 1 of y as another variable. Okay. You can introduce new variable for that, or you can just keep eyes on that. Don't make a change. That's equation 1, equation 2. So you can say just equation 1 minus equation 2. Then you will get 1 of x plus 1 of x, 2 of x, and then negative 1. Now 1 plus negative 1, 2 is negative 1. So from here, x should be equal to negative 2, right? Why? Because x is in denominator. You multiply this, right? And you do the cross product, and then you get negative 2. So once you get negative 2, then you get, well, then you get by the first equation, right? 1 over negative 2 minus 1 over y equals 1. Right? So I can solve for y, because 1 over y equals negative 1 over 2 minus 1. Yeah, right? So it's going to be negative 3 over 2. All right, so how do you get a y? Y just turn upside down. So you get answers. But you can also use substitution, make it easier to view the equations. So if you let, we call it substitution. If you let x to u to be 1 over x, y to be 1 over y, v to the 1 over y, then this equation, look at this is the equation, right? Those two equations change it to a linear equation. Okay, so then it's much easier to view it, right? To work with it, because those two are linear equations in u and v. They are linear equations in u and v. Okay. Then you find the u and find the v. Once you find the u and find the v, you can find x and y. Okay, right? You can find x and y. Okay, so you can add those two equations together. Okay, you can add those two equations together, right? And if you use substitution, it's also okay. I can say by equation one, u equals 1 plus v, right? Then you plug into equation 2. In the place of u, you put the 1 plus v, and v equals -2. Right? Right? Finally, and 2v equals -3, and v equals -3 over 2. Okay, so you get v. Okay. And then again, use a u equals 1 plus v. So it's a 1 minus 3 over 2. It's -1/2. All right, so you get u and the v, then you can get x and y, okay? Because 1 of x is going -1/2, right? Yeah. Wait a minute, let's get to what is x here, okay? So 1 over y equals -3 over 2. So from here, you can get x, right? X is -2, y equals -2 over 6. Okay. All right, now I'm going to ask you to work on the following problem. 2x minus y equals 3. 4x plus y equals 5. Find the value of x plus y. Okay. I'm not asking to find the value of x and find the value of y. I want to find the value of x plus y. What are you going to do? Well, you can try this to find the value of x and find the value of y, then add them together. You also ask yourself, is it necessary to do that? Okay. All right, anyone have answers? Angela with huh? And Jordan, XU, do you have answers? Yeah, I'm going to call your names, okay? If you have figured out, let me know. Ethan, Kelvin, Yan, Christina Lee. I have 2 girls, there's 3 girls, okay? Christina Lee, Christophe, and Sophia. Oh, 5, 4, 录小，录小，小录小。All right, so let's take a look at equation 1, equation 2. Now you can find x plus y, no problem, just solve this equation. Find the value of x, find the value of y, done. Right, add them together, then. And how do you find the x and y? Well, use the elimination method. You can get x first, right? I'm going to show you the not the good way, okay? But not the good way is you add the equation 1 plus equation 2. I get 6x equals 8, right? So x is going to be 8 over 6. I simplify 4 over 3. Then I use any of the equation, let's say equation 2. Y equals 5 minus 4x, 5 minus 4 times 5 over 3, okay? Which is going to be negative 1/3, right? Negative 1/3. Negative 1/3. So you have x and y, so x plus y equals 4 over 3 plus negative 1/3, and that is going to be 1. You still can solve it, but that's not a good way, not a good method. Okay, and the next one, a good method. Good method is you look at these two equations. Let me write down this two equation again. 2x minus y equals 3, 4x plus y minus equals 5. What I'm trying to do is, here's the equation 1, here's the equation 2. I find out equation 1 minus equation 2 minus equation 1. I cannot eliminate x and y, but what I got is 4x minus 2x is 2x. Y minus negative y is 2y. 5 minus 3 is 2. So if I divide both sides by 2, I get x equals y. X plus y equals y. That, I think that's what that is, that's probably Andrew did this way, because he did it pretty fast the last time. Yeah. All right. Good. Now we have to deal with 3 variables. X minus 3y equals negative 10. X plus y plus 2z equals negative 2. Negative x plus 2y plus z equals 5. Wow. So 3 equations, 3 variables. How can we do that? Okay. Well, I think it's not too bad. Okay. You can have that many ways to do it, much more free. Okay. You can use substitution to get the system of any equations of 2 variables. Okay. You can keep the equation 1 and eliminate the z variable in equation 2. Okay. Then you get the equation in x and y. But let's try a different way. Okay. So yeah, and there are many ways to do. Okay, I just want to show you a different way. That's minus by equation 3. Equation 3 z is going to be 5 plus x minus 2y. Okay, then I plug it into equation 2, so I can get rid of the z. So x plus y 2z. Z is 5 plus x minus 2y. And equals negative 2. Let's simplify. This is the equation I need. Okay, so x plus y plus 10 plus 2x minus 4y equals negative 2. Okay, so x plus 2x is 3x, y minus 4y is minus 3y, and 10 is moved to the other side, it's negative 12. Okay, then I divide both sides by 3. Okay, that's my equation 3. Okay, great. Now we go back to equation one. Equation one is 1 minus 3y equals negative 10. That's equation one, remember. So now you have equations x and y, in x and y. But you have to be careful. Any step, if you make any computation mistakes, you will not able to get the right answer. So we eliminate the one variable z using substitution method. Then you can solve it whatever you want, right? You can use substitution, you can use a elimination method. So I can try this equation 3 minus equation 1. How about like that? I want to get rid of x. So negative y minus negative 3y, that's 2y, right? Right? Yeah. Negative 4 minus negative 10, and 10 minus 4 is 6. So y equals 3. Right? If y equals 3, then you can use a third equation equals y minus 4. It's negative. It's a 3 minus 4. It's a negative 1. All right. So x is negative 1, y is 3. Then you can use any of the equation to get z. Okay. Yeah. All right. So you get x and get a y. So z is going to be 5 plus x minus 2y. Remember, right? So you get 5 plus negative 1 minus 2 and 3. Okay, it's going to be 4 minus 6. It's negative 10, I think. This is going to be this is not going to be negative 10. Let's double check. Okay, y is going to be 3, x is going to be negative 1. So z is going to be y plus x minus 2y. Let me check. Yeah, it's not negative because of 4 minus 6. That's going to be negative 2. It's 4 number. It's negative 2. So finally you get x equals negative 1, y equals 3, z equals negative 2. And you can plug those numbers for x, y, z into the original equation. If they match, that means any of the equations holds, then you solve the problem without making many mistakes. Without making any mistakes. All right, let's try next one. X minus 2y plus 3z equals negative 7. 3x plus 2y minus 5z equals negative 13. 2x minus 4y minus z equals 14. Okay, now you have 3 equations, 3 unknowns. How do we solve for x, y? X, y, z. Okay, the idea is that to use one of the equation to get rid of the one variable from the other 2 equations. Then you get the 2 equations, 2 unknowns, then you can solve for that. Okay? So it's you can use any of the equations. Okay? It's equation 1, equation 2, equation 3. I think I can solve for x in the first equation. Or you don't like z, you can use a third equation. Okay? So if you by the third equation, z equals 2x minus 4y minus 14, right? And then in the equation 1, equation 2, you replace z. Okay, x minus 2y, yeah, plus 3z, so 2x minus 4y minus 14 equals negative 7. Okay, let's see, this is z, right? It's let's simplify it, be careful, yeah. It's a 6x, that's 12y, and 14, 42, right? And then you get 6x, 1x, 6x, 7x, negative 2y, negative 12y is negative 14y. And 42 is moved to other side, okay? Okay. I think it's 35, right? 35. Okay. So that is the equation. And you really want to simplify, then you get the fractions. Okay, that's equation 1. That's coming from equation 1. Okay, so I keep it like this, okay? Then use the second equation. Second equation, 3x plus 2y, and here's 5z. So this is 2x minus 4y, and that is negative 13, okay? So 5z in the place of z replaced by 2x minus 4y minus 14. So 3x plus 2y, and here's 10x, 20y, and 14 times 5 is going to be 70, right? Okay. So let's simplify, okay? 13x minus 2y negative 18y. And the 70, move 70 to the right-hand side. So which is going to be 7 and 57. Wow. So now we have a trouble, right? We have two equations. 7x minus 14y equals 35. 13x minus 18y equals 57. So those are the two equations. I call it equation 4, equation 5. And from here, are you able to get the answers? Okay. Yeah, we hope no mistakes, okay? We hope we did not make any mistakes. It's easy to make mistakes, okay? So let's try to see whether we can yeah, how do we solve this? Okay, how do we solve this? Right, so I prefer to add them together maybe, even, right? So I get 20 and maybe you get a much better number, right? So this is pretty complicated, right? The numbers are pretty strange. Okay, so far I have no mistakes I make, okay? It will be surprised you get answers, no, simple answers, okay? I'm just trying to random try. I don't see any simple ways to solve it. So I get 20x, and this will be 32y, and here add them together, 35 plus 57. 35 plus 57 is 92, okay? So yeah, that both they are divided, that divisible by 4, yes, divisible by 4, it's a 5x, okay, 8y, and equals 23. Now, this equation does not help you too much, okay? So maybe we have to use a stupid way to do that, okay? So just to use substitution, okay? So you have to deal with fractions then, okay? So by equation 4, okay, then x is going to be, okay, not too bad, it's 2y plus 35/7. Okay, 35/7, actually it's simplified. This equation is simplified. So it's 2y plus 5, right? Yeah, 7, 14, 35, okay? The 14 is 2 times 7. All right, that's great. Then you plug into the second equation, 12 by equation 5, x is going to be 2y plus 5 minus 18y equals 57. That's simplified. It's going to be 26y plus, okay, so it's going to be 56, 65, yeah. So 26 minus 18 would be 8y, right? 8y, right? Then 57 minus 53, it's also -8, right? So y is -1, great. Y is -1, then x is going to be 2 times y plus 5, and that is 3. So x is 3. So once you get x and get y, then you can get z using any of the equation, okay? Using any of the equation. So we can go back to original equation, let's say by the first equation. First equation says that x minus 2y plus 3z equals -7. So x is going to be 3, y is -1, and 3z equals -7. You can get z, right? Okay, so 3z is -7, and 5 minus 5, and that is going to be -12. So z equals -4. Okay, z equals -4.
I found like a better method. Like,
yeah, I'm not saying my method is better. We got into, you cannot see at the very beginning what is the best method.
Like, one of the equations, it's like 13x minus 26y equals 65. Like, you can each subtract, you can divide each side by 13, and you get x minus 2y equals
mm-hmm.
like 5, I think, and then like you can just, and then like that makes it much more simpler. You can multiply each side by 13, and then you x would be canceled.
Yeah. Oh, okay. Yeah. I just say, sometimes you begin with some steps. You don't want to back up, then you end up with a long way to at the end and get to the end. Okay. Yes, there are some way. If you add the first two equations together, and for example, that's much short way. If you do that. Okay. So I just said that multiple, instead of what I'm doing is using standard method. I just solve for one variable from one equation and plug them into the other two equations. Then you get the equation of two variables. Okay, that's a pretty standard way to do, but does not mean the best way to do. Okay. Now there are some equations looks pretty simpler. Okay. For example, like x over 2 equals y over 3 equals z over 4. Now, you have 3 variables, but sounds like you're only given 2 equations. Actually, you're given 3 equations because the first equation are indeed two equations here. X over, because there are 2 equalities there, right? So x over 2 equals y over 3, and y over 3 equals x over 4. So to solve this problem, you also introduce the variable. You let them to be t, okay? Then you get x equals 2t, y equals 3t, z equals 4t, okay? Then you plug into the second equation, and x plus y plus z is a 2t plus 3t plus 4t equals 18. Okay, and from here you get a 9t equals 18, t equals 2. So once you get 2, the value of the t, then you can get x value, y value, z value. So 4, y equals 6, z equals 8. Okay, yeah. Now, sometimes you don't get the unique solutions, okay? You don't get the unique solutions, but you want to get some kind of a value, determines the value of some variable. Suppose you have 3 equations, okay? We assume that x times y times z is not going to be 0. We are only given 2 equations, x minus 2y minus 4z equals 0, and 2x minus y plus z equals 0, okay? We cannot see, look at, you have 3 equations, 3 variables, 2 equations. You cannot determine all of the solutions, okay? Unique solutions. You are going to get infinite many solutions. What we want to find out is the ratio x to y. Right? Right. Well, in this case, you just express your solution x and y in terms of z. So you're assuming z is some number, just, yeah, don't need to pay attention too much, yeah. So you just solve for x and y in terms of z. Then you find the ratio. If possible, you can cancel z, okay, right? So let's look at these 2 equations. How do you solve the problem? For those 2 equations, how can you solve it? Okay. Can you use the elimination method, substitution method, elimination method? You cannot add them together quickly, right? You have to, well, if you want to use the elimination method, you can multiply the first equation by 2. So 2x, 4y equals 8z, okay? This is coming from equation 1 times 2, okay? Equation 1 times 2. Right, and then this is a 2x minus y equals negative z. So that's equation 3, equation 4. Let's do this, right? I only modify equation 1 in order to use the elimination method. Then I do subtraction. You can say equation, let's say equation 3 minus equation 4, doesn't matter. So 2x minus x is gone, right? Negative 4 minus negative 1 is negative 3y. Negative 4y minus, so plus 1, okay? And 8z minus negative z is going to be 9z. So from here, y equals negative 3z, okay? So y gets negative 3z. Then you can get x using the first equation. Okay, so first equation, 2y plus 4z. So 2 is negative 3z, and 4z, so I get negative 6z plus 4z, negative 2z. Okay, so you have x and y, both are expressed in terms of z, then you can find the ratio. X and y equals negative 2z, negative 3z, and then the answer will be 2 over 3, because z will be canceled out. Okay, so this is how do we so you are going to get the infinite many solutions. We can express the general solution in the following form. Okay, so look at it, right? Z can be arbitrary value. So why not? We can set. We can let z. Let z to be. Let's let z to be t, right? Then you get x equals negative 2t. Y equals negative 3t. So you got all of the solutions. Okay, t is arbitrary, so you get a family of solutions. infinite many solutions. Okay. Okay. Yeah, let's stop here.